A big thank you to all my patrons who support the Engineered Mind podcast. Hi and welcome to the Engineered Mind podcast. In this podcast we cover topics such as engineering, artificial intelligence, neuroscience and other interesting topics to educate, inspire and engineer people's minds all around the world. I'm your host Joseph, and for this episode of the podcast I'm happy to welcome the one and only Yannic Kilcher to my show. Yannic has a master's degree in computer science from ETH, and now he's a Ph.D. student and researcher at ETH in the data analytics lab by day and an AI YouTuber by night. In this awesome podcast, Yannic and I talked about what adversarial examples are, what opportunities and risks they imply, if AI is biased, the main intention of why he created his channel, thoughts on the democratization of AI, and of course the usual question rampage and the meme review with the AI meme boss himself. For updates on upcoming podcasts, projects and videos, make sure to follow me on Twitter as well as on Instagram. To join my weekly newsletter engineeredmind.sh where I share exclusive content, visit yusuf.substack.com. And now, ladies and gentlemen, here's my podcast with Yannic Kilcher. Hey Yannic, welcome to my podcast. It's really a pleasure to have you on my show, and first of all, thanks for accepting the invitation.
Thanks for having me. It's a pleasure.
So today we want to talk not so much about theoretical stuff. Let's see how it goes, but we have a surprise for you at the end as well. So what do I want to start with? Of course, for those of the audience who does not know who Yannic Kilcher is, can you explain who is this Yannic and what does he actually do?
I lead a bit of a double life. At day, I'm a PhD student at ETH in Zurich, and our lab does more of a foundational research in deep learning. So there's a lot of optimization. I personally do research in adversarial learning, adversarial examples and robustness. And we have quite a few topics in our lab, but it's all kind of foundational research, the type you'd see at like ICML or NeurIPS or things like this. And then at night, respectively, on weekends and in my free time, I have a YouTube channel where I explain research papers, and I just sit down and scribble on the paper and explain it, and people seem to enjoy it, even though it's like an hour long of me talking.
Yeah, actually, I have a lot of work to do to watch some of your videos which you have released recently, and you have roughly more than 60,000 people following you on YouTube. That's insane.
Yes, it is absolutely insane. I did not know there was such an interest for, as I said, the content is not action grabbing. It's not, it's not like I don't do any tactics to grab your attention or anything. It's remarkable. Yeah.
Marketing genius. Did anyone repost your YouTube videos on Twitter and then something like got viral? How was it?
It happens every now and then that some let's say bigger name posts or links or retweets or something like this, but the growth was fairly organic. There are some videos that just had a very high, for some reason, a lot of attention. Ironically, the attention is all you need video. So the video on that paper was the main driver of views for the first years of the channel, actually. Mm-hmm. And then I started doing more videos, and now I also have other videos that gather quite substantial amount of views.
That's crazy. I'm really happy for you. I see, like, especially channels who aren't like the mainstream kind of channels, explaining like what is machine learning, how does it work, and so on. And seeing your channel blowing up is really amazing. Before we jump more into more other topics related to the channel, can you explain what are these adversarial examples you work on? What is it actually on a deeper level?
Oh, no one knows that. But so the phenomenon of adversarial examples has been known for a while, and it's this notion that you have these image classifiers, for example, and they can tell you what's in an image. For example, is it an airplane or is it a car or something like this? And we teach, these are sort of the intro to deep learning. You're going to build some classifier on images. And we know that we can take such an image, and the the network can be very sure what's on it, and it can be correctly so. And we can make tiny changes to that image, like in the sub-pixel range. So in the range where you as a human cannot possibly perceive it, or it's really hard to perceive it. And we can make that classifier completely change its mind about the picture. So even though to you as a human it looks exactly the same, we can make the classifier say almost whatever we want. And this is called an adversarial example, because the notion of what the human sees and what the classifier sees is so different. And this has been expanded now to most of continuous signals. So there are adversarial examples, for example, in speech recognition, where it seems like you're just listening to some music, but in actuality, the music you listen to is giving your Alexa orders to order a bunch of stuff off of Amazon, and all kinds of things like that. So it's a really interesting topic, and there are a lot of opinions about why these adversarial examples exist, what exactly is wrong with them, what to do about them. But as I said, that's opinions, and the why do they exist on a deep level, I don't think that's understood quite yet.
Mm-hmm. What for you is the most fascinating idea about adversarial examples? I mean, you kind of framed it, but what for you is like the absolutely mind-blowing about adversarial examples?
Well, that they exist, I guess, is already a bit mind-blowing. I am a follower of the cult of Madri. So Alexander Madri is a professor who specializes in and around these adversarial examples, and him and his group have put forth sort of a hypothesis of what's going on there, and they basically say that these adversarial examples, they're not abnormal. They are sort of consisting of real features that are really informative. It's just that these features are so small that we as humans can't see it. But these features are actually what the classifiers, they do pay attention to these features. And when we make an adversarial example, the classifier really sees whatever we want it to see in terms of these features. So it's not like an aberration. It's not a specific kind of noise, or it's not off. I guess it's off the data manifold in some way, but they've shown through very clever experiments that this is really a problem of real informative features being manipulated rather than noise. And I think it's an interesting idea, and I think it's correct.
Mm-hmm. I think in the nature of the human brain, we always think about this kind of dystopian scenarios that could happen. Where do you see these adversarial examples could potentially be used for, and also scenarios where they could be used for, like, benefiting humans?
Yeah, so there is a big discussion about the real world implications of these adversarial examples. And they are usually a bit overblown. So what I could do is I could go in front of a self-driving car, and I could print out the very specific pattern, and I could just hold up that pattern, and the car would think it's a stop sign. Or I could put a little pattern on a street lamp, and I could make the car think that it's a green street light instead of a red street light, or it's a one-way street in this way instead of in that way, and so on. So technically, there are these sort of attacks that I could run. It's questionable how well they would work, because usually these cars, they have multiple overlapping systems. So they don't only drive by computer vision, right? They have LiDAR, and they have maps, map knowledge, and they have multiple systems recognizing these things, and so on. And these adversarial examples, they need to be kind of well crafted, right? And then there's always the question of, I can just go and smash a car with a baseball bat. If I really want to cause a car to crash, there are probably easier ways to do it then. So it is questionable what the true real world security, let's say, implications of these things are, but you can definitely think of some. In terms of applications of where these things can be of the benefit, you see this in GANs. So generative adversarial networks, they continuously the generator continuously produces exactly such adversarial examples, only for the discriminator then to come in and adjust to that, right? To be like, nope, until the generator produces these adversarial examples such that they actually look like real images. I mean, it's a bit different, but there's definitely a very strong connection there. And I would say that's one of the good applications of adversarial examples.
Mm-hmm. What it reminds me a little bit of is that you are probably some of the white hat hackers in the field of adversarial examples, and that there's also the other side of the black hat ones who might misuse it, right?
Yeah, I guess I haven't, as I said, I haven't really seen any outside of academia, anyone who actually does something, let's say, evil with adversarial examples. There are related things that I'm a bit more worried about, like there is the field of training set poisoning, where you introduce training set examples to a data set, so you know that this is going to be trained on at some point. You deliberately introduce examples such that the classifier will behave in a certain way. That I can see some applications for that, good and bad. But in terms of adversarial examples, I'm not sure. Maybe once deep learning systems become more widespread, you might see more attacks like this. Like you could get a really cheap loan if your loan application is fed through a deep learning system. You could change your birth date to the exact number and your height and so on, and then you could get like a really cheap loan or something like this. I don't know.
Yeah, you mentioned this training poisoning. What immediately popped into my head is, I mean, we are both active on Twitter. We always see these debates of is AI biased? How is your opinion on that?
Well, I've made an entire video on this, for which I've gotten into a lot of trouble. Not for the point I make in the video, though, which was mainly that it really depends on what you mean by biased. And this word is so overloaded that it is almost impossible to have a clean discussion about it. So if you say the classifiers are, let's say, societally biased in that they make different decisions for different groups of, if we apply an algorithm to people or so, or even different groups of inputs, then yes, most of the classifiers will be biased in the sense that the training data sets are also biased. So they will somehow take that over. But then there is also the sort of statistical notion of bias, which appears in the bias variance trade-off. And there you can introduce bias in the sense of, actually my classifier does something different than my training distribution because I regularize it a certain way, because I build my model in a certain fashion, because of the architecture. And these can interact, right? So what a model can do is it can exaggerate a bias that's already there in the training data, or it can sort of even it out and so on. But I feel that this sort of discussions, especially in the 240 characters domain, there's no room for defining your terms clearly and having a sort of an opinion, an in-between opinion.
Yeah. Let's see. I mean, this is always a heated debate, and I mean, Twitter isn't the best place, I guess, to get into an argument. Let's put it that way. Regarding your YouTube channel, do you want to say anything else to that topic, related to that topic?
No, I'm okay. It's just like the pure statement I made that that bias, the bias in classifiers. So the societal bias in classifiers will be taken over from the training data set. That will already get you into a heated debate because people say, well, you leave out so much other stuff and so on. But I think it's all a matter of cleanly defining your terms. And then I think most people will actually agree on most of the things.
Yeah. Regarding your YouTube channel, you also mentioned like some of the people or listeners might know that you do this kind of paper, quote unquote, reviews or go through them step by step. There is a reason behind it why you do it. Can you explain us why you do it? Why you go through the whole paper?
Well, it's mainly to force myself to read the paper. So I at some point, I noticed that when I read papers, I skip a lot of things. I just kind of look at it and be like, oh, yeah. And I never really read it thoroughly. So I thought, okay, if I need to explain it to someone, I need to read it well. But then I have no friends, so can't explain it to someone. So I thought I'd just, record it and put it on the internet. And maybe someone else who is interested in the same paper can, instead of reading it, just look at my video. So I thought there was this sort of added benefit for someone else. And especially I felt so there's a lot of material on the internet for beginner level, up to like master's level. You can sort of get a university education on the internet, right?
Yeah.
There's Coursera, YouTube. I mean, there's so much good content out there for you to get started. And it's harder, but you can get there. And then there are talks by researchers, but these are often like, there's no way, right? You look at a pre-recorded talk from NeurIPS, no. If you have a master's degree and it's not in exactly machine learning, there's no way you can get through that. So I thought there's a bit of a hole where you take someone that is at like a sophisticated level of math and engineering, and you sort of guide them to this bridge to this current state-of-the-art level of research. And yeah, so that was my goal.
This is super cool, Yannic. I really appreciate it. And I think from a little bit over 60,000 subscribers, if you inspire, let's say 1% even, I think that makes a huge difference for the future. So we have to appreciate channels like yours. So really good job there. When it comes to the paper per se, I had the idea, maybe could you differentiate between like beginner, intermediate and expert level on papers? That would be something I would be interested in. For example, you take a paper, let's say the famous for GANs, the first paper about GANs, and this is kind of beginner level, quote unquote. Did you think about something like this where you say we take papers and split it into beginner, intermediate and advanced levels?
Yeah. It is hard. I mean, a related idea would be to explain the same paper at a beginner, intermediate, and advanced level.
Yeah.
It's like three cooks cook the same meal, but one is a pro, and so on. That would work. In terms of papers, it's a bit different probably because each paper was the state of the art at its particular point in time, right? It's not like the GAN, like it's not like Ian Goodfellow sat down and be like, okay, I'm gonna do a really basic thing right here,
yeah,
right? And I'll write it for for introductory level. No, that was the height of knowledge. That was the forefront of knowledge. That was unknown territory at that particular point in time. And even though it's well known now, it is nowhere. It is not really easier to read the original GAN paper than it is to read some other paper today. So yeah, I'm not sure. That's why I'm saying there is not really something to really bridge the gap there, other than a university program to which most people don't have access.
Yeah, that's the thing. Yeah, I mean. Yeah, you're absolutely right. But do you think it's becoming a bit easier with the plethora of materials out there? Let's say you go back in time and you only have one GAN paper, the one from Goodfellow, and then moving forward in time, then you have not only the paper from Ian, but also other papers related to GAN, which you can then build kind of a synergy effect. You have several papers which you can combine, and you don't understand the mathematics, and you go to this resource. And do you think it's easier the more we move forward in time?
Yeah, sure. I mean, the well-known ideas are also going to be fleshed out more, right? And it often happens in math as well that someone will come along and find a much easier proof for something that was already proven, right? But now they find a much easier proof. it's like, oh, I just proved this in these 4 lines, right? Like, how are you ever so dumb to spend 20 pages on this? And it's a bit the same in that, GANs, they get fleshed out, a lot of stuff gets built around them, Medium posts get written, and people talk about them. So it definitely becomes easier, but it also means that, the frontier of knowledge will move on. And now the frontier of knowledge is right over here.
Mm-hmm.
So
yeah,
and that's going to be hard again.
Yeah. When I talk about Medium, do you also see, or are you concerned that a lot of misinformation will be spread about neural networks, deep learning in general, or AI in general?
Sure. I mean, that's the fun of it, right? So, I mean, it's the cool world. Like, I'd rather have lots of misinformation than sort of everything being
standardized,
Ministry of Truth approved, right?
Yeah.
It's a bunch of people that are trying to just make sense of stuff and write stuff for each other and hope someone reads it and so on. And eventually, the good stuff will bubble up and the bad stuff will sort of maybe have like a bit of success here and there, but it's a cool world where anyone can publish things. I love that. And I encourage, even if people don't get something fully correct, I don't see why they shouldn't put stuff out there.
Yeah, I mean you have an immediate feedback loop, so to speak. I mean, if you publish something, then people will get back to you and say, hey, this is completely nonsense what you wrote. But then you have a feedback loop, and then you can adapt from there, right?
Absolutely.
Yeah. When it comes to your top papers, what top 3 papers would you recommend to somebody going into AI? Doesn't matter which field now, but top 3 papers you would recommend.
Going into AI, well, this is a hard one, but I would say I always loved the residual networks paper.
Mm-hmm.
That is just that, to me, that's just a nice paper. Like, it's clean, the idea is clear and so on. It needs a bit of pre-knowledge, but it was a really cool paper at its time. So I like that paper. Yeah, other than that, I don't know. Maybe go back to the classics. Like, well, the classics in deep learning are maybe the AlexNet paper.
Mm-hmm.
That, and then maybe go even further back to whatever Hinton and Lecan wrote in before the neural network winter or during.
Yeah. Okay, we'll leave it at that, Yannic. Otherwise, it will be too overwhelming. We also want to talk about the hard world as a PhD student. Can you maybe walk us a little bit through how it is to be a PhD especially in the field of AI?
Yeah, it's very special, I would say, because, I mean, being PhD students is sort of its own thing rather than having a real job in the rest of the world. But in the AI field, due to the fact that it's just exploding right now, and it has been exploding for the last 5 years or so, I feel, and I just have I have n=1 experiences, right? So I don't have much, but from what I can see, this fact that this is exploding brings a number of challenges. First of all, it's insanely competitive.
Yeah.
So when I started the PhD, I would never get into a PhD program today. Like, when we have a new job open, so many people apply, and the ones that we pick to interview, they all already have publications. It's insane. It's absolutely insane. Like, to expect master students to already have publications, have research experience, and so on, like that. The PhD is supposed to be for that, to teach you like how to do competent research on your own. But so that's the one thing. And then of course you have to search your niche, and it's hard because the big companies are also in the game. So other than I don't know, math research, in AI research, you're sort of competing not maybe directly, but you are competing for attention, for slots in a conference, like accepted papers with Google, which is like the most powerful company on the planet, and with Facebook and with all of these types of things. So it's definitely a weird world, but it's also a very fun world and an interesting world. And even though I said it's very competitive, it's absolutely not impossible to get into a PhD. So
yeah. How do you see it when people now listen to this podcast and they might feel a bit discouraged? I mean, we talked about so many resources being available online, and you can build your stuff. You can even build your GitHub kind of reputation and gather stars and whatnot. I mean, that's still possible, right? This is the beauty of the progress, I guess, that you can build stuff and degrees, quote unquote, become less important as compared to like maybe 10, 15 years ago. How do you see that? Do you think this is a huge opportunity for people now delving into AI?
Yeah, definitely. So I just described PhD, right? And PhD is one thing, but in no way this is in no way the only path. I think that machine learning or data science, however it might evolve in the next few years, is going to be very valuable for businesses, and businesses are already struggling to find good data scientists, good machine learning engineers. You might not get to implement the most, latest fancy schmancy GPT-3 in the business that you're actually working at, but still, competencies like this, I think, are going to be quite valuable in the job world. They're going to be probably mixed with software engineering jobs. So maybe you'll be like half a software engineer, half a machine learning engineer. But and I think a PhD is in no way the only way. So yeah, you can be self-taught, you can go boot camps, you can build up your reputation, as you say, on GitHub and so on. Yeah, there's lots of paths to get into this.
So one last question before we jump into the, how I call it, question rampage or massacre, however you want to call it. We have 10 questions prepared, or 11 questions for you, Yannic, and you have to answer with one sentence optimally, maybe one word even. So the last question before we jump to this question is, do you think it's better to be a generalist than a specialist nowadays?
Probably, because it depends on your field, but in this field, the world is changing very fast.
Yeah.
So we've gone from NLP being parse trees and lexical parsing, semantic parsing, and so on, and then reasoning over these trees with rules. Machine translation used to be we parse this sentence and we apply these rules, right? And maybe they have some statistics, but we've gone from that to whatever LSTMs to now transformers in like 10 years or less. And it's crazy how fast everything's changing. And that's not a small shift. That is a completely different skill set. And so I think whether this is a generalist or a specialist, I think you need to be a specialist at teaching yourself new things quickly and not be afraid of just changing the way you do things.
Yeah, that's a beautiful way to put it. So now, Yannic, before we jump, we have two more steps now, then we're done with the podcast. So the next step would be I have 11 questions prepared, and optimally you give me one answer and one answer only. Start with the first one. OpenAI or DeepMind?
DeepMind.
Twitter or Facebook?
Twitter.
Okay. What advice would you give yourself 10 years ago?
Eat better.
That's a good one. Best book you ever read?
"12 Rules for Life."
That's a good one. Yeah. Favorite AI movie or series?
I don't have one.
Okay, we'll leave it at that. Favorite hobby?
Street music.
Mm-hmm. Best paper you ever read?
Yeah, I'd say ResNet.
Mm-hmm. Most inspirational person for you?
PewDiePie.
Okay. You could do a 1-year internship in any company you want. Where would you do it?
The NSA.
Programming language of choice for AI?
Python.
And the last one, favorite framework for AI?
PyTorch.
Okay, that's great. Would have done that. Okay, let's start with meme number 1. You can also comment on it if you want, and I'll show it instead.
Someone asked why you never stop talking about machine learning. Yeah, I mean, I don't know. What do you do when you're a machine learner and a vegan? It must be conflicting.
Yeah, definitely. Do you like that meme, or do you think it could be funnier?
I don't know. Is it really a meme that people don't stop talking about machine learning?
I think there are some memes. For example, the guy with the red hat. When you don't talk about machine learning for like 5 minutes or so, this is also a funny one. Yeah. What would you give it? 1 out of 10 in terms of funniness?
A 3.
A 3. Okay. Yeah. At least gotta step up my humor. Meme number 2. And maybe you can also comment on that one.
The math behind deep learning, import Keras, machine learning. Yeah, I mean, oh well, this was the early days. Now every framework is like this, right? Now every single framework is super easy, and you just spin it up and you Hugging Face whatever your model. It's one line of code. Keras used to be the only one. Like all the others, even TensorFlow was, even Torch and PyTorch at the beginning, they were terrible to work with, and you needed to know engineering, and I felt you needed to know quite a bit of the math as well, just to be able to engineer the stuff. So yeah, definitely truth. So truth value 10, funniness 9.
Okay, at least 9. Nice. Okay, meme number 3.
Learning MLDM from university. Online courses, YouTube articles, memes. Yeah. There is some that, right?
I mean, how I learned about like the let's say quote unquote difficult memes is I actually watched your video where you did a meme review with your friend.
Yeah.
And I was like, first I don't get it, and then you explain it a little bit. Okay, now I get it.
This might work, right? It might spark some. It would be funny if you sat someone in front of just like 200 memes, and after that you let them write like a test to a deep learning course and see how far they'd get. It'd be super interesting.
Okay, let's move on.
Yeah.
Number 4.
AI, machine learning statistics. Yeah, this is a good meme, right? It's set like the business world. The business world is a lot like this, where they say it's AI, but ultimately it's like a tiny bit is a learned system, and then around it is just classic software engineering. But Yeah, that's what I said when we talked about this in practice, that it's utopia to think we can learn our way through everything, but rather machine learning is a nice piece that you can fit into an ecosystem. So
Yeah, second that.
again, truth value 10 out of 10.
Next one.
When you initialize your ML new friends, weight was 0. Yeah. Oh. Yeah. That was, I mean, we didn't know in the early days. We didn't know. We didn't know how to initialize stuff.
I also put you on this. I also put you on the spot a bit because some memes might be not very funny. So if they're not funny, just let me know. It's also cool.
No. This is. I mean, this is because you search is. I mean, you okay. Zero is maybe 1 because you go nowhere. But would you, like with batch norm? Yeah, probably you'd still go nowhere.
Do you also have other evil ideas which we could use for our noob friends in ML?
I was always wondering about this question of, if you were like a mad scientist, like the classic mad scientist from the comic books.
Yeah.
But you only had machine learning at your disposal. So, and you need to do the most evil thing with machine learning. What would it be? And you can't, like, it can't just be like machine learning being a small part. Like, I'm going to build a killer robot and it has a computer vision system. It needs to be like, let's say, over 2/3 of the entire system needs to be the machine learning component. What would you do? And I haven't heard a really good answer yet.
We can work on that, Yannic. If you want to become an evil, like, we can work on a comic where you are the evil one.
There's always machine learning for good and all of this stuff. And I thought it would just be, a question of machine learning for evil.
Yeah, why not? We can work on that. Okay, let's move to the next one.
MATLAB is a real programming language. Well, MATLAB now has a neural network package and all. And I remember my master's studies was like full MATLAB. It was crazy. It was still before deep learning. It was all MATLAB.
Yeah, it's quite powerful. People still make fun of MATLAB not being capable of doing ML, but it's matrix operation in the deep sense, right? And it's quite efficient in matrix operation, doing matrix operations.
Oh yeah. It's a weird language. It's
yeah, Yannic, we can leave it at that. That is a weird language. Okay, next one.
When you see machine learning code written in Java, I'm sickened but curious. Again, I'm showing my age, but their deep learning for J was a thing. Like, it was a thing. There was a time before TensorFlow, before PyTorch, like, so LuaTorch was around, but sort of, and Theano was around, and that was kind of the hip thing that not many people knew about. And the frameworks other than that were like Caffe was really, and deep learning for J was actually a thing that people used. It was ugly, it was terrible, but people used it, and I'm so glad we moved away from this. I've programmed a lot in Java, and now I realize that I don't want to do that anymore.
We are so spoiled, right?
Yes, definitely.
Okay, next and last one. I'm not sure if you know him. Like, it's a YouTube.
When you're the only friends who uses PyTorch instead of this, why I am more successful than you. I am a big fan of just using whatever is the best for whatever you need to do right now. Like, especially in research, there's not really a point in being ideological here.
Yeah.
just use whatever gets you to the end. Though I guess the new hip thing is Jax. But yeah, he makes a lot of these clickbaity titles.
Yeah, I don't know.
I think
like
I've seen him around.
Yeah.
Is he the one like that is like the ex Google engineer?
Exactly. Google
And he
tech
puts it
lead.
into like, yeah, it puts it into like every like into 90% of his video titles.
Yeah.
Ex Google engineer says this.
Actually, I think what he does is he puts in brackets as a millionaire, because this guy's a millionaire.
We should do that. We should do that. We don't have to say what we have 1 million of. Like, I have 1 million worries.
Yeah.
We should, yeah.
But it's clickbaity. Yeah. Also coming back to your videos, which are not clickbaity at all. But I like the thumbnails though. They are kind of clickbaity, your thumbnails.
Yeah, you have to.
Yeah,
you have
course.
to. Even paper titles are becoming clickbaity now. So
Yeah,
I don't feel
right.
bad for making my videos a bit clickbaity.
Yeah, absolutely.
Yeah.
Yeah, I mean, we'll leave it at that, Yannick. Thank you so much for participating in this funny/unfunny meme review and podcast in general. Is there anything else you would like to tell the audience before we wrap things up?
No, thanks for having me here. This was awesome.
This is awesome. I wish you all the best for your channel, and I hope you grow to, let's say, 150K until the end of 2021. That would be awesome.
Yeah.
Awesome.
Hope so too.
Cool. And then with that being said, thank you so much, Yannick. And maybe there will be a second part in the future. Let's see. If you publish a paper, I'll be more than happy to. Yeah, okay, you have your own channel. You probably go through your own paper then. Let's see. Okay, then take care, Yannick, and thank you so much again.
You too. Thanks a lot.
Bye-bye.